Hello, this is a mathematical demonstration using GeoGebra dynamic worksheets to explain how exponential and logarithmic functions work. We're going to start first with exponential. So we have an exponential function in this form. We can see here that we have four different parameters. And a is multiplying this, b is the base, x minus c is the exponent, and then d is an independent term. So let's see what these numbers do. We need to change three values, and we need to change a, b, c, and d, and we need to give them three values each, and then write down in an investigation log what that does to the curve, the exponential curve. So a, for example, as we move it up, we can see that we're just multiplying the exponential. Okay, and we can see how it does. Please note how a makes this point and this point different. Remember that these are the axis intercepts. Okay, now b is going to be the base. As we can see, once b increases, then the slope of the curve is much bigger, increases. Eventually, if b equals 1, it's a straight line, which makes sense. Okay, it's a horizontal straight line. If b is negative, we can see that the function decreases. Okay, so this was exponential decay, and the other one was exponential growth. Yeah, so increasing, decreasing. Now c is going to be easier for us to adjust. We can see that the whole thing moves horizontally, and d also very easy, the whole thing moves up and down. Okay, you might want to set up values of d, for example 0, c the same, c 0, and before you start changing the values of a or even b. This might make things easier. Okay, but that is up to you. A, for example, I guess you can set it up to 1 and then change b, for example. Now we can also have other investigations. In the yellow part we have a vector v that has coordinates a and b. We can see here the vector, and what we're doing is we are translating the whole curve by this vector. So this is easy now. We change the value of a, so that's the x coordinate of the vector, and obviously the yellow curve moves right and left. B, same thing with this, yeah, up and down. You need to do 3 different values of each. Finally, the green part of the investigation, we now have 2 parameters p and q, and what they do is they transform the function this way. So q is multiplying x, p is multiplying the whole function, and then we can see here how this green curve is affected. Obviously, if p has negative values, the whole thing is negative, but then when it has positive values, we can kind of like stretch it that way in the y-axis, and then the same thing as it goes for the x-axis, and it can also be negative. Okay, well, this is all for the exponential functions. For the logarithmic functions, we're going to do something similar. We have a function in this form, so it's the logarithm in base a of all of these, and then we can obviously change these values here. So we can see what happens when we change a. Okay, remember that a is the base of the logarithm. If the base of the logarithm eventually is stretched to 1, then you know something is happening. You need to write that down and what is happening. When eventually we have values of the base that are bigger than 1, look at what happens. Same thing for small values. What happens when the base is 0, and what happens if there are negative values. Okay, and remember the domain of the logarithms, so you need to write these things down in your investigation log. Now b, we can see here that is multiplying the x minus c factor. Okay, c is going to be easy because all that we're doing is we're moving horizontally, and same for d, but vertically. Okay, then again you might want to set the values of c and d to 0 probably, so that you can investigate the others more easily. Okay, even better, you might want to set up b to be 1 when you are investigating a. That could be interesting, okay, to do. Yeah, remember, it can have positive values, can have negative values, and sorry, it can have positive values, it can have values between 0 and 1, and values over 1, I mean. Okay, that's all. Now, same thing for the yellow part. So we have a vector that has coordinates a and b, and this is how it gets translated, and this is the easy part. We can just see how it gets translated horizontally and vertically. And then same things for the green part. We have two factors p and q, and they are stretching the y first, and the x-axis, the q, because it's multiplying times x. Okay, and that's all for now. Thank you.